I'm live now.
Yes, sir, you are live.
Okay. Hello, everyone. Welcome to the live session on the course of Nuclear and Radiochemistry. I hope you are enjoying the lectures. So far, I understand that 20 modules of half an hour each, roughly, are completed. And that the first 4 weeks, in fact, includes the fundamentals of nuclear chemistry, including radioactivity, radioactive decay, nuclear structure and stability, nuclear models, alpha, beta, gamma decay, and the interaction of different types of radiations and their detection. So if you have any questions related to this particular part that is completed, feel free to write in the chat box in YouTube, and I'll try to answer them. In case the question is of different type, maybe I will try to send later on, but more or less I try to answer the questions right there. So do write on the chat box if you have any queries, any questions. You can ask me any type of questions. Don't have to feel shy. Questions can be of any level. Don't have to bother. So just whatever doubt you have in your mind, you can write in the chat box. Yes. Okay. It's not from course, but since you are a listener, can you please guide us for some career option after nuclear radiochemistry? Okay, very good. I understand that such a course on nuclear and radiochemistry, one will be always thinking about what will be the scope for the employment after attending this course. So you see, this nuclear radiochemistry subject, these are more of fundamentals of radiochemistry and nuclear chemistry. But this knowledge is used in many applications in the industry, in healthcare, as you will come to know later on in some of my lectures. The last 10 lectures, I have tried to give the details. What are the areas in which one can use this knowledge, which is where there is a scope for employment. I can just elaborate on that. For example, the healthcare. Now you must be knowing about the SPECT analysis, single photon, like the stress test, the imaging of the heart or other organs of the body using radioisotopes. So there are courses like postgraduate diploma in radiological and hospital physics. There is a 2-year course where the students are taught the fundamentals of radioactivity, their detectors, and the radiation dosimetry. And subsequently, there is an internship in hospitals. So you can use this knowledge in that course. Every year, there are some students joining that course. Some of them are even sponsored by the industry, and they become the radiologist, the hospital physicist in hospitals, particularly cancer hospitals. So one of the areas is in healthcare. The second area is in industry. Industrial radiography is an area where it is used in troubleshooting or even in the radiographic non-destructive testing in different industries. This all will be clear in the last part of my course. So there are a lot of requirements for people who are having knowledge in radiochemistry, radiation detection and measurement. And so this is another area is industry. Then another area is food processing, food technology, food preservation, and agriculture. You will see later on that by radiations, one can induce mutations in the seeds and produce improved varieties of crops which have the attributes which you need. Similarly, you can extend the shelf life of the fruits, the vegetables. You can disinfest the different food products from the microbes. There are huge applications. Like in industry, you can modify materials to produce desired characteristics. So, radiation-induced polymerization. You can prepare materials of your interest. So, it's a whole lot of area will open up if you have interest in this area. So as you go along, you will see later part. I have included the lectures on applications of radiochemistry in different area, particularly healthcare, agriculture, industry, environment, and others. I hope I'm able to give some explanation to your query. Can you provide the PPTs of each weeks? The PPTs, I think they have been converted into videos. I can ask our colleagues in NPTEL to give response to this. I can share my PPTs. I have no problem. But what is the mechanism of that? I don't know. I have to know from the NPTEL team. NPTEL team, you can respond to this question. Can you provide the PPTs of each week's?
Yes, sir, we will provide.
I have uploaded the I have uploaded videos, but I can send my PPTs to NPTEL, which they can share with the students. I don't know whether it is possible for the NPTEL team. But I can also share my PPT with the students if they send a mail to me. My mail already is there during my videos. You will see my email ID. Okay. Next question. Radioactive sources in academic institutions for research are kept only after permission from BARC. Yes. Is there any limit on the quantity of such sources? There is when the university students or such research scholars are using radioisotopes, they will be mostly in the range of microcuries or sub-microcuries. There is an exemption limit from the Atomic Energy Regulatory Board. Atomic Energy Regulatory Board, in abbreviation called AERB, is the nodal agency in the country which will regulate the use of radioisotopes in any area outside the Department of Atomic Energy. And therefore, if any university want to use radioisotopes in they should write to the Atomic Energy Regulatory Board. There is a division called Radiological Safety Division. And in that, if you go to the site of AERB, it is available to public, you will see there is an exemption limit. So the low activity sources are exempted from, there is no need to take permission for low level activity sources. That exact number I do not know, but it is available in the website of AERB. www.aerb.gov.in. If you go, you will know all the details about what are the sources, what kind of activity you can handle, you can keep without any exemption, without any permission, and for higher quantity you will need the permission. In fact, there is a course for radiological safety officer, that's called RSO. Any big industry where they are using radioisotopes, like hospitals or industry, there is a requirement of a RSO, and RSO training is taking place in the Department of Atomic Energy, where this is like a 21 days course. After attending the course, if you pass in the examination, you get a certificate of RSO. And it is also related to the question it was asked in the beginning by one of the students, that what is the scope of this in the applications. So those students who want to use radioisotopes in industry or any area subsequently, they can think of attending this course, which is done by our BARC. There is this radiological safety officer course is the 21 days course. One has to come to Mumbai for that. And after successfully come, in fact, my lectures will be helping you in that particular course. So this is one of the areas where you can use this course to find an employment later on. So permission you need from AERB to use the sources, but the exemption limit is there that you will find in the AERB website. Related to the course material, if you have any questions, you can ask. Also, this if you recollect my lectures, or maybe yes, already it has been covered. A simple thumb rule, if you whatever activity one is handling in the laboratory, the radiation dose given by that sources will be in microsieverts or nanosieverts, which is very, very small, negligible compared to what we receive from the background radiation. So a typical X-ray we do, or even the CT scans give much more doses. Or if somebody does a stress test with the radioisotope, that gives the higher doses than the radiations that one gets using radioactivity, because the sources are microcurie, less than microcuries. And when we are using an X-ray, it will be in a much higher doses than the radioactivity handling. Yes, there is one question. Does HBNI provide postdoctoral fellowships in nuclear radiochemistry after PhD? In general, there is a postdoctoral research fellowships given by DAE. They are limited. There is one KS Krishnan Fellowship, KSKRA, KS Krishnan Research Associate. It is there. I think not every year, probably alternate years. Some postdocs are taken in the DAE. HBNI also had taken some postdocs last year, I remember. 2 postdocs are already working in HBNI. So there is a input in terms of postdocs, but it's not very high. But what I can tell is that there are no inspired fellows. There are some inspired fellows working in the Department of Atomic Laboratories after PhD, and one can definitely try to join the department and later on look for an employment related to nuclear energy. You can write to me. My email ID, I hope you know, B.S.Tomar1957 at gmail.com. I repeat, B.S.Tomar1957 at gmail.com, so that it can guide you if you have interest in particularly applications of radioisotopes in different areas. It will be more clear when you attend the last 10 lectures of my lectures. So that you will be more appreciating how this subject is find applications in society. Any other query of any type, need not necessarily be related to the curriculum. You can ask general questions also. In fact, I have also included some of the lectures, where one can do frontier research in the area of nuclear radiochemistry. The later part of my course, you will see. So both, it is the fundamentals and application. See, if some of those of you who are pursuing your PhD must be attending the course on research methodology. And in research methodology, the different types of research are being done. One is that the fundamental research. Now it can include the blue sky research, which may not find an immediate application. And then there is a pure applied research, which is purely need-based. Sometimes may not be even required based on a fundamental research. But then there is another research called the huge inspired basic research. So you do basic research, but you have something application in your mind, like the Louis Pasteur's germ theory. So Louis Pasteur understood what causes the fermentation, what causes the spoilage of the milk, and understood the germs which are responsible for this spoilage of the food, the milk, and the wine, and then gave the theory, and later on found out the techniques for pasteurization. The technique of pasteurization came from the Louis Pasteur. So even this area of nuclear radiochemistry, if you do fundamental research in this area, you will be in a better position to apply this subject in an application. So whatever applications have come up from the radioactivity, you will find somewhere some fundamental research has gone as an input. So modern day research is a combination of fundamental and applied research. To understand the things fundamentals, you will find solutions. So troubleshooting of a problem in any subject in a field requires the fundamental knowledge of that area. Any more questions from students? Very good question. Do you have idea about how India is managing its radioactive waste of high level, as nuclear reactors are being increased in India and also radioactive materials used is increasing? Okay, good question. Not directly related to the course, but I'll be happy to answer this question. You see, in India right now there are 22 power reactors operating, producing electricity, and we have what is called as the closed nuclear fuel cycle. The nuclear fuel cycle is closed means when we have a reactor burning the uranium is undergoing fission. It is producing plutonium also, and that plutonium and uranium, after some time, it becomes difficult to extract more electric energy, and so that we call it the spent fuel. So we replenish the fuel from in the reactor, and whatever is take out, we reprocess it to recover the uranium and plutonium. And in the process, what we get is the high-level liquid waste. That high-level liquid waste contains many useful radioisotopes like cesium-137, strontium-90, ruthenium-106, which are useful in industry and many other areas. So, as a normal practice will be to do the waste management of this high-level waste. So, normal practice is that this high-level waste is concentrated by a factor of 4, and then it is vitrified in a glass matrix. There are suitable borosilicate glass matrices where you vitrify the contents of the high-level waste. The high-level waste will contain small quantity of uranium, plutonium, which you recover 99 point something percent. There will be still some few percent, 0.1, 0.2% of uranium, plutonium, plus the fission products and minor actinides like neptunium, plutonium. So they are vitrified in the glass matrix. So you have a glass. Why we want to vitrify? Because we don't want these isotopes to come in the environment to influence the biosphere. And these vitrified glass matrices are now put in canisters and later on in overpacks of carbon steel. And right now, they are all being stored in a subsurface facility because the cesium-137 half-life is 30 years. So in 30 years, the activity will become half. The dominant gamma activity in the high-level waste is due to cesium-137. So after a few decades, when the activity becomes low, there is a work going on to find a suitable deep geological repository. The repository will be a few hundred meters down, and right now we don't have to immediately do the deposition, but they are being stored because the rate is very slow. The number of canisters being generated is not very high. So these are being stored, they are air cooled, and suitably when we have a site for depository after a few decades, all the high-level waste, vitrified form of high-level waste will be deposited in a deep geological deposit. But before that, the new trend is to recover the valuable products like cesium-137, strontium-90, which are finding like 137 cesium is used in blood detators to hygienize, to if there is a microbe in the blood, they will be removed killed by the gamma radiation. And there are many other applications of 137 cesium. Strontium-90 is being used in healthcare as a parent of yttrium-90, and yttrium-90 is used in therapy. So these are, once they are recovered, the net residual activity will be quite small. But even then, it contains some radioisotopes having half-life of hundreds of thousands of years, like neptunium-37, americium-241. And so that we need to make sure that the radioisotopes do not come to the biosphere. There is, in fact, a research going on trying to see how much time the repository will be able to retain these radioisotopes, and that comes to about hundreds of thousands of years. So intense research is going on, and it is not immediate requirement to find a repository and bury the radioisotopes. So the major pathway for the radioactive waste management, that is the high-level waste, is to define them glass matrix, which will be later buried in a repository. There are other low-level wastes. Low-level wastes containing small activity. They are managed by other means. There are intermediate level wastes which are concretized and stored in the subsurface area. So there are mechanisms to do the management of the different types of level waste: low level, intermediate level, and high level. So far, it is a well-proven technology to manage the high-level waste from the nuclear facilities. I hope I'm able to satisfy your query. In fact, you can even think of visiting our institutions like IGCAR, Kalpakam, or BARC. If you are in an academic institute, then you can always try to visit BARC. There is a public relations office, PRO. They are very happy to facilitate your visit to the institution. So you will get a first-hand knowledge of how the things are being done at the department. Many students come for internship. The students who are in the final year of their MSc or who are doing PhD, they come for short visits to BARC and get exposed to different development techniques. West India at present uses boroscale glass, and also geological repositories being found in India or outside India. Yes, every country, particularly those countries which have a program, nuclear program, like France, Finland, Switzerland, United Kingdom, United States, they have a repository program. And in fact, Finland, in fact, have gone very advanced stage. They have already marked the area. They have marked the, see, there is like, it is you have to find the host rock. So the host rock can be granite, it can be clay, it can be even salt domes. So there is a research going on how the radionuclide will migrate through this host rock. So it will be few square kilometers. So that host rock also is studied for the migration behavior of radionuclides. And now, when you place this the glass matrix, which is which is sealed in a canister, and this canister in turn is sealed in a overpack of carbon steel, and then between the overpack and the host rock, there is a vacant area, so that there is a buffer material filled or backfill material. It's a clay. So there are bentonite type of clays. The clays are aluminum silicate type of clays. So these clays will also have the property to retain the radioisotopes. And so this is what is called an engineered barrier. The glass, the canister, the overpack, and the buffer, the backfill material are called the engineered barrier, and the host rock is the natural barrier. So there are several layers of barriers so that we make sure radionuclides do not go into the biosphere. So not only in India, outside also this research is going on. The second question is, because India has huge population, I think if it is stored in one place in India, it will be problematic for the people and our humans residing near to the geological repository. Okay, so that is what is the job of the nuclear scientists, to dispel this fear among the population. As I mentioned, the high level waste, whatever radioisotopes it contains, the ones which are very highly radioactive, like cesium-137, 90 strontium, now they are being recovered to be used in many applications. What you are left with is the minor actinides, long-lived minor actinides, neptunium, americium, and some of the long-lived fission products which do not have much of gamma rays. So the program, when the repository is made, repository will be able to retain these fission products for a time which is more than the lifetime of the. In fact, I had one figure. I cannot show you now, but calculations have been done that the repositories will be able to retain the radionuclides for a lifetime, for a time much more than the few half-lives, 10 half-lives. So in 10 half-life means, in 10 half-life, activity goes down by a factor of 1,000. So a curie will become a millicurie will become a microcurie. And so, in fact, I must tell you the mantra, Dr. Bhava, in fact, the message that he gave to the people in the nuclear industry, that the Department of Atomic Energy has to set example of the safety, radiological safety. So we are most careful about ensuring that the radioactivity is not released to the human environment. So whenever a technology is going to public domain, so much of research has gone to make sure that these radioisotopes do not land in the human environment. So it is taken care. You don't have to feel that radioisotopes will be released and then people will be affected by them. But that is why you will find it is not that suddenly you deposit the isotopes in the repository. So much of research is going on by modeling, experimenting in the laboratory, in the field, and then you finally go to the repository. So it is not a job of a one day or a one decade. Maybe several decades of research will be done before a decision is taken that radioisotopes can be placed in the repository. In fact, let me also tell you that you must have, I don't know whether you know, there is a concept called accelerator driven subcritical technology, ADS, accelerator driven subcritical. That means the heavier actinides like americium, neptunium, you can transmute them in an accelerator, and once you divide them into small fragments, the half-lives are shorter. So the ADS program will obviate the need for a repository. So once you have an accelerator driven subcritical system, long-lived actinides, minor actinides like americium, neptunium, will be split into fission products, and these fission products are short. So there is research going on even on the ADS. There is one more question. If earthquake of high scale comes, will not geological repositories worrisome? Earthquake in Turkey or in Gujarat? Yeah, see, there are always, you can have this called scenarios, different scenario. Now, uh, you must be seeing the buildings, how the design of the buildings has changed over the years. The buildings, there are buildings, high-rise buildings, which can withstand earthquake of very high magnitude. We are learning with experience. Even in the nuclear technology, we are learning with experience. And any nuclear facility, when it is established, there is a called what is called as a design basis. The design basis includes the earthquake. What is the effect of the earthquake on a nuclear facility is factored. When a reactor is made, when any nuclear facility, aircraft crash, earthquake, all kinds of scenarios are factored before the facility is commissioned. So you are very right. There is always a apprehension in the mind of the people. What will happen if there is an earthquake? So the seismic, in fact, there is a full seismic department in our department who analyze, who in fact see the simulation. What is the kind of earthquake which can happen, and how the design of the facility is made to make it safe from this kind of disasters. So they are indeed taken. Your apprehension is genuine. The department takes care of all these eventualities when the design is in fact before the commissioning, even the design stage, these things are taken. See, for example, an aircraft industry makes an aircraft, and the aircraft is flying in the air, right? There is a possibility that the aircraft may crash. There have been some cases, but people do fly. And the quality control of these aircraft manufacturers, 1 in 1 billion, there is a possibility that the aircraft may crash. So that is the kind of quality control. Similarly, in the nuclear industry, there is a there is a quality control. There is ISRO also. They have huge stakes in the programs, and the quality control is the most important part to make sure that the program is successful. Similarly, nuclear industry, any design, any facility, one makes sure that the effect of the natural calamities is minimum. Do India have a separate budget to projects related to nuclear waste immobilization? No, it is not a separate budget. Nuclear waste comes in the budget of the Department of Energy. It is a part of the DAE budget. So when a project is sanctioned, they have to, like what they call it, the cradle to grave. That means you do the mining of uranium. From that to the final management of the waste that will be generated, a complete is taken care. So when you want to make a reactor, it is also factored what will you do with the waste. So all the research is being done when you finally the project is commissioned. Yes. Any more questions? Yes, there is a question. How can I visit radioactive waste facility? So you don't have to specifically mention radioactive waste. Usually you want to visit BARC. There are many centers of attraction in BARC. Radioactive waste facility is being one of them. How this the high level waste is rectified, how the glass is made, how the where it's stored. So definitely one will be welcome to visit the radioactive waste management facility in BARC. You have to write to the what we call as the human resource development division, head of the human resource development division, to make a visit to BARC. And in fact, it will be better that if your another department or your guide writes to the head of the human resource development division of BARC, then it can be arranged. It is very there are so many students visiting BARC for educational tour. So out of whatever students are attending, maybe all join. Some students normally a group of 10-15 will be at a time will be asked allowed to enter in one group. So if there are so many people, I can also facilitate this visit by you people to be asked. There's no problem. As long as you are interested in seeing the facilities, learning the how the research is done in the department, you are most welcome. Can my students also visit along with me? Sure. In fact, it is meant for students and faculties. So any students who are studying in MSc or doing PhD, they are welcome to BARC to see all the facilities are being run. At Homi Bhabha National Institute, also we can facilitate your visit to BARC. If you are in Chennai, southern part, we can do it in ITCAR Kalpakam. Very good. I am sure many of the students will be interested in visiting our two facilities where the nuclear research related to fuel cycle is being done. And both the places, ITCAR as well as BARC, visits can be arranged. I am in Delhi. Yes. So if you are in Delhi, you can come to BARC. So do try to visit these institutions. So whatever I have discussed in the lectures, that impact will be more if you visit the facilities, see the people who are handling radioactivity. In fact, we also conduct the workshops in different institutions in the country, and the students will be handling the radioisotopes as a part of that workshop. Morning we have lectures, afternoon we have practicals where the students handle the Geiger-Müller counter, sodium iodide counter, and do different types of experiments, energy resolution, dead time, statistics. Different experiments are done. So we conduct workshops, different parts as a part of our outreach program. Any other question? No more questions. You can even write to me if you have any further queries. You can write by mail to me. I'll be happy to reply to your mails. Okay, I think there are no further questions. I understand the main objective of this live interaction session was to find out from the students if they have not, if there are some doubts, the queries related to the curriculum. But I'm happy that the students have asked questions related to the atomic energy program of India, which is also very valid, that you are conscious of the subject itself. See, the radioactivity subject, we are always carried away by the harmful effects of radiations. But when we go to do an X-ray, we don't bother about this harmful effect because it gives benefit. And right, the corollary of that is there, but whenever we use radioactivity in any area, we have to see the cost to benefit ratio. So by taking an X-ray, I come to know if there is a fracture. By taking a MIB test, technetium 99 is used in the MIB to find out the health of the heart. It's called stress test. So we inject radioactivity into the human being, the blood, and take the image of the heart to know what is the health of the heart, how there is damage to the heart after the heart attack or angina. So there is a cost to benefit ratio. So if the benefit is more, you don't mind paying for that. So similarly, benefit is high, there can be some slight like this cancer treatment. When we radiate people, particularly the tissue, the cancerous tissue with gamma radiations, cancerous cells are killed. But it may also, radiate the nearby normal tissue, normal cells, and which we try to minimize. So we have to always see the benefit from the radioactivity and try to minimize the damage. So if there is no benefit, then we should not be using it. Like in troubleshooting in industry, if you'll see later on that there is a leakage in a pipeline which is running hundreds of kilometers from the crude to the refinery. And by using radioactive tracers, you can solve the problem with much less cost, much less time, and much less manpower. So there is a huge benefit to the industry or to the country. And therefore, there is a requirement of such techniques where we use radioisotopes. Radioisotopes, we have to see what is the kind of activity you are handling, what the level of activity you are handling. When you are handling sub-microcurie, radiation doses are negligible. You handle curies, you take adequate precaution, you protect the radiation workers from the radiation. So we have to protect it. Like when you take an X-ray, the operator is also taking the X-ray film. When he's exposing you to X-ray, you see how he protects himself or herself. So it is we have to understand the thing and do it. Okay, so it looks there are no further questions. So I'm happy that you have asked some very genuine questions related to nuclear energy. I would have been more happy had there been questions related to the curriculum that I had covered in my part. But you can always ask me later on also. Feel free to write to me by mail and I'll be happy to answer those questions. Okay. So thank you and all the best to you. Over to NPTEL team at IIT Bombay.
Thank you, sir.
Thank you very much. Thank you.